Good morning. So my name is Hannelie and this is Chelsea. So we're both junior software developers at BBD. I work for DHA in the Pretoria office and Chelsea is working with APSA in Joburg. So our agenda, we're gonna go through some basic terminology and then I'm gonna explain why to optimize your queries. And then we have 4 examples and then we'll be taking questions.
Hi everyone, so just some basic terminology based around our topic today. So what is a query? A query is a written instruction that we execute to perform an action on our database. We can use queries to insert, update, delete, and select data within our database. Then what is SQL? SQL stands for Structured Query Language. SQL is the name of the language that we use to write our queries. SQL can help us to communicate with our database. Then what is SQL Server? Microsoft SQL Server is a relational database management system. It's developed by Microsoft. We use MS, which is an abbreviation for Microsoft SQL Server Management Studio, to manage our database or databases. We can execute and write queries using SQL scripts in SSMS. And then just in case no one has used it before, this is just an overview of what it looks like. For instance, here you would have your database or many databases. When you expand the database, you can then see your tables. And when you expand your table, you'll be able to see all the columns. And then you could also see sometimes like the data type and whether it's a foreign key, primary key, etc. Then this is called a query. You can have multiple queries within a single SQL script. These tabs here indicate that these are SQL scripts. If you want to create a new SQL script, you'd click here, New Query. If you want to execute your queries, you would highlight it and click Execute. So yeah, that's just a brief overview of what SQL Server Management Studio looks like.
Okay, so some reasons why you need to optimize your queries. So to minimize the performance time is important because your users, if it takes too long for your users, they won't be happy and you'll lose money. And also it's important not to spend too much time on unnecessary optimizing, because the more time you spend on a query that isn't really going to help you that much, the more money you're going to waste for your employer. And then also the slow queries can slow down performance and computing resources, and it can also cause a loss for the users. So the user can actually lose service for a short time. And then, it could also be possible to find a completely different solution, and that is also a good way of optimizing. So yes.
Okay, so we've got 4 examples today to show you of how you can optimize your queries. I'm going to be demonstrating example 1 and 2, and Hannelie is then going to be demonstrating example 3 and 4. So our first example is going to be about using select star versus using select all columns. So it's actually more efficient to, when you use a select statement, to list all the columns as opposed to using select star. So some reasons why we say this is because, first of all, the table structure can change after a query has been written. So we're going to get more to that in a scenario on the next slide. Then not all fields are indexed, forcing a full table scan. Also, select star is seen as an anti-pattern, meaning it's not very good design practices to use. And then if your code depends on column order, select star could hide an error waiting to happen if a table has its column order changed, meaning that if you have a code base that executes, that has queries written in it, and it is dependent on the order of your columns within your database, if you go and modify your database, there's a very high chance that your queries within your code are going to break. So now if we come to a scenario, so here I have a customer table, which looks something like this. We have our first name, last name, and age. We then create a view. This view is going to return all the customers in our table that have the first name Bob. If we run our view, we see that we get this entry, this result. Now say I want to add an additional column to my customer table. Say this is called birth country. Now we see if we run our view again, this birth country column doesn't show. This is because views are static. If you change your table structure, you will need to also then change your view and recreate it. So why we think you should create views with the column names instead of saying select all is someone who perhaps is new to your development team might not see a problem with this view because maybe they don't know what columns should be shown anyway. So if you have, say, for instance, view, stored procedures, functions, it's more intuitive to list all your column names as opposed to saying select all, because people will know what's going on, people will know what should be displayed. Select star is nice to use if you're just wanting to briefly see how many columns your table has, how many records there are. Maybe you're trying to populate a database, you just want to quickly see if your execution worked. But definitely if you are running views, stored procedures, functions multiple times, and you have multiple people managing the system, it is better practices to list the column names so everybody knows what's happening. So yeah, that's that example. So our second example is about using inner joins instead of wheres to join tables. So first of all, the first reason is some people may agree, some people may disagree. But when you write your query, sometimes using an inner join looks a bit neater. It might be easier to, if you want to expand on that query to add more tables that you join together, using an inner join might be easier to do that. Then the biggest thing is that it can impact your query performance. So for anyone who doesn't know, what an inner join is say now you have this table A, you have table B, an inner join will return you a table with all the rows that have something in common between table A and table B, depending what you're joining on. So if we look at a scenario, here are two queries. One is using a where statement, the other one is using an inner join. You can also see the syntax between a where and an inner join. So we are trying to select the full address from the customer and customer address table, and we are trying to join it on address ID. So what your inner join will do is it will create something called a cross join, which is also known as a Cartesian product or a Cartesian join. So if we look at this picture on the right-hand side, what a where statement will do is say now you have this table meals and drinks. It will create a cross join between those tables, creating a temporary table with all possible combinations of those two tables, and then it will filter that temporary table to see if any of the records match the where statement, as opposed to an inner join, which will just directly query your table. So you can see this can be very inefficient. So as you can see, a cross join, say this has 3 rows, meals has 3 rows, drinks has 3 rows. Your resultant temporary table would be 3 times 3, which is 9 rows that it needs to go and filter by. So with SQL Server, it actually, whenever it sees a where statement, when you're trying to join tables, in the background, it automatically uses an inner join because it knows that an inner join is better in terms of performance time. But there are some database management systems that don't do this. So that's just something to be aware of when you are writing your queries. So Hannelie will now explain example 3 and 4.
Cool. So example 3, we're going to talk about using wildcards. For those who don't know what a wildcard is, you use it to search the strings to get a certain string you want. And in SQL Server, it's symbolized by a percentage sign. So you get a trailing wildcard, and you also get a leading wildcard. So the leading wildcard is placed, a percentage sign placed before the string you're searching for, and then it ends with that string, say the letter M, and there can be any characters or any length of characters before the letter M. And then a trailing wildcard, it starts with the letter M, and the percentage sign after the M means that the string, anything can be after that in the string. So yeah, it's the main way to perform string searches. So here in the first example, we're gonna use the letter M to search through a database. So this database this table has 3 million rows. So here we're gonna use both the trailing and the leading wildcard. So this query took 2 minutes and 10 seconds to execute to look through words with the letter M. And this can also be at the beginning or the end of the word. So here in the top slide, it's a leading wildcard. So the percentage sign is in front of the M, and the execution time is 8 seconds. So that is 2 minutes and 2 seconds faster. And the one below it uses a trailing wildcard, and that is also 2 minutes and 1 second faster than when you use both. So where possible, use a single wildcard for the most efficient execution time. Okay, next example. So example 4, we're going to talk about filtering with where or with having. So using where instead of having is much faster. So where is better for filtering queries based on conditions, since it limits the number of records pulled, but having collects or retrieves all the records in the table. So also with having, it first does a where clause before doing the having. So it's a 2-step process, and also the having takes all the data and then filters through it. So yeah. So here's the first example, or the example of using having. So the example we used is we want to return all the people that have a date of birth between a certain range, and we're going to use where, and we're also going to use having to illustrate the difference. So here, the having that pulls all the records and then applies the filter takes 2 minutes and 15 seconds. So yeah, and on the next page, using where, so it directly filters and it takes 1 minute and 44 seconds. And it's a 1-step process. And yeah, this table also has 3 million rows. So
yeah, so that's our examples that we wanted to show you guys. Then just if I can show you in SQL Server, Hannelie, can you see my SQL Server screen?
yes.
Okay. So in SQL Server, if you want to say, measure your timing on your queries to compare, I'm going to show you some tricks on what you can do. So if you go here to query and you click include client statistics, and then I've just got a simple select star statement on a very small table. And when I run this, I will get this tab here that says Client Statistics. And when I click on it, it will actually show me all the time statistics of my query. And you can run multiple trial runs on your queries. You can run a maximum of 10 trial runs, and you can get an average of that. And that might be able to help you if you want to compare multiple queries to each other. Another thing you can do is you can write out this command, set statistics time on, above your select star query. And when you run this, it will give the timing of your query in messages in milliseconds, as opposed to the one that SQL Server automatically provides, which is in hours, minutes, and seconds. So that's just some useful tools that you can use in SQL Server to measure the time of your queries.